Okay, in our previous lesson, we learned how to store a single piece of data, a single book, in our memory, our library. But a very important question arises. What if you want to store a collection of different items together, all under a single name? This is where we introduce our first data structure, the list. This time, imagine you are not taking just one book to our temporary street library. Instead, you want to display a collection of different books, but you want to keep them all together as one single package. Let's say you have 4 books. A green book on mathematics, an orange book on art, a yellow book on chemistry, a blue book on English. You take all these books and tie them together with a rope, creating a bundle. Then you place a single sticker on the whole bundle with the label T. You take this bundle of books to the library. The librarian, our PVM, looks at it and confirms that no other bundle is already named T. Then they do something very important. Internally, they assign a position number to each book inside your bundle. And the library system is built to always start counting from 0. So the order looks like this. The green book, Math, is at position 0 in list. The orange book, Art, is at position 1 in list. The yellow book, Chemistry, is at position 2 in list. The blue book, English, is at position 3 in list. Now think about this. A little while later, you go back to the librarian and ask, "Can I please have the item at position 2 from my bundle T?" Which book does the librarian give you? Of course, they will go to your bundle, find the 3rd book, and hand you the yellow book, Chemistry. This is the entire essence of a list, an ordered collection of items under a single name, where you can access any item by its position number, which we call its index. Okay, let's now create our bundle of books example on our computers. We are going to give our commands directly to the PVM, our librarian. I will create a new file named mylist.py. Step 1, creating the bundle. To create a list in Python, we use square brackets, like this. And we separate our items with a comma. Let's create our bundle of books. We will name it T. T equal to, open square bracket, close square bracket, first item mathematics, comma, art, comma, chemistry, comma, English. That's it. With this simple line of code, we have told the PVM to create a bundle named T that contains 4 different string items. Step 2, viewing the entire bundle. If you ask the PVM to give us T, what happens? Print T. Let's see the results. Python 3 mylist.py. Run. Look, it gave us the entire bundle, exactly as we defined it, in the same order. This is like the librarian bringing you the whole set of tied up books. Step 3, requesting a specific book by its position, or we can say index. Now let's ask for the book that is at position number 2. Remember, counting always starts from 0. To do this, we write the name of the list, followed by square brackets with the index number inside. Like this. Print T between square brackets, we write index. Perfect. It gave us the yellow book, Chemistry. This is exactly what happened in our library analogy. The PVM went to the T bundle, selected the 3rd item, and gave it to us. Step 4, a quick test. Okay, what if you want to get the first book, the green one, mathematics? What index number do you need to write? Print T0. Exactly, mathematics. Mm, because the first item is always at index 0. Practical summary. Use square brackets to create a list. Use comma to separate the items. Use list name and between square brackets, write index to access a specific item. Alright, before we start, I want to post a quick note. In our fundamental lessons, to help you build a deep and intuitive understanding, I used a few key analogies. I used the street library as an analogy for your computer's RAM, and I used the librarian as analogy for the PVM, the Python engine that works behind the scenes. So as we go through the practical examples today, you will hear me use the phrase, let's tell the librarian. When I say this, I am using it as a simple and easy way to refer to the action we are asking the PVM to perform. It is just a tool to help you connect the practical code to the concepts we have already learned. Now let's get started. Scenario number 2, replacing an item. Now let's tell our librarian, please replace the book at position number 2, chemistry, with a new book, physics. T and index number 2 equal to physics. Print bundle after replacing T. Let's check the result. Mm? Scenario number 3, adding an item to the end. This time, let's tell the librarian to add a new book, history, to our bundle. Please name dot append function history, print bundle after adding, comma T. The result. Mm? Scenario number 4, remove an item by its name. Now let's ask the librarian to remove the art book from the bundle, wherever it is. T dot remove function art. Print bundle after removing art, comma T. Let's check the result. Mm? Scenario number 5. Accessing from the right, negative indexing. How do we ask the librarian for the first book from the right? Let's say last book equal to T minus 1. Now print the first book from the right is last book. Let's check. Scenario number 6. Getting a range of items. Slicing. How do we ask the librarian for arrange books? For example, the book from position 1 up to, but not including position 3. Slice of books equal to T 1, 2, 3. From 1 to 3. Remember, print the books from position 1 to 3 are slice of books. Let's check the result. Scenario number 7. Finding the total number of items, length. Let's ask the librarian how many books are currently in our bundle. Number of books equal to length function. Print there are, comma, number of books, comma, books in the bundle. Let's check the result. Scenario number 8. Finding an item's position, index. Let's ask the librarian. Can you tell me the position number, or we can say the index of the English book? Position of English equal to t dot index function English. Print the book English is at position, comma, position of English. Let's check the results. Scenario number 9. How can we ask the librarian to count how many English books are in our bundle? Count of English, T count English. Print there are, comma, count of English, books named English in the bundle. Let's check the results. Scenario number 10. Combining two bundles. Concatenation. Now let's ask the librarian to combine two separate bundles into one large bundle. For example, bundle 1 are math, chemistry, physics. Bundle 2 is art, history, geography. Combined bundle equal to R plus S. Print the combined bundle as combined bundle. Scenario 11. Removing the last item. Pop. How do we tell the librarian to simply remove the very last book from the bundle without needing to know its name? Print current bundle T. Remove book equal to T.pop. Print the book that was removed is removed book. Print the bundle now is, comma, T. The result. This line shows the list before remove book. And this line shows the list after remove book. Scenario number 12. Reversing the order of the bundle. How do we ask the librarian to reverse the order of the entire bundle? Print bundle before reversing, comma, T. T dot reverse function. Print bundle after reversing, comma, T. Scenario number 13. Sorting the bundle. And finally, how do we ask the librarian to sort the books in our bundle alphabetically? Print bundle before sorting T, T.sort function, print bundle after sorting, comma, T. Check the result.